Hello. Last time I believe we talked about the interest and compounded interest that's involved with mortgages and credit. And what we're going to look at now is what happens when we are collecting interest or trying to save to get annuity. So let's just kind of look at that. It's kind of going the other direction, but it is very closely related. Now, before we get too far into it, just a notation, because otherwise you're going to get your answers wrong. On page 534 of the textbook, they point out that they round up. Because if you round money, if it's part of a dollar and you round it down, then you might end up being slightly short. And so you're going to want to end up rounding it up to the next dollar amount. So always round up when you are calculating these payments. Particularly, it says that for annuity payments. Round up for annuity payments. So now let's look at what annuity payments really are. On the value of annuity, there is a deposit, P, made at the end of each year for an annuity, and that pays an annual interest rate of R, which is again in decimal form, compounded once a year. Then the value of the annuity after T years is. A is your value. It's kind of like your amount, right? P is your periodic deposit, though. It's not principal like it was before. It's how much you are putting in at the end of each year. R is your interest rate, and T is the number of years you're going to leave it there. Now, this one is just once a year. The interest rate is compounded once a year. So I have in very small print, but I have a reminder down here of what that formula is. And here's an example of where it might look like on your homework. It is going to say, find the appropriate formula. Thus far in this lesson, I've only introduced one formula, so why isn't that automatically the appropriate? Well, when you go to do your homework, you will have several to choose from. So how do you know this one's appropriate? Because it is compounded annually. And annually is once a year. Okay, this is the formula for when it's compounded once a year. Now the periodic deposit is P. My interest rate as a decimal will be 0.04 or 0.04. And 30 years is T. So I have A is equal to 8,000, bracket, parentheses, 1 plus 0.04, of course I could combine those, raised to the T, which is 30, minus 1, close bracket, and all of that is over 0.04. Well, that's an ugly formula. If you're using a real basic calculator, you just want to start here in the middle and just kind of slowly work your way out, add and raise it to the 30th. Take that answer minus 1, take that answer times 8,000, and so on. But here on a graphing calculator, I'm going to be able to put all of that in at once. So first of all, to get a fraction, I'm going to go alpha y equals enter. And that just sets it up for me to type in a fraction. So now 8,000. Now rather than brackets, really brackets were just like parentheses. It's just a second set of them. So I'm just going to use my parentheses to open for the brackets and then open for the parentheses. 1 plus 0.04, close for the parentheses, raise it to the 30th. I have to use the right arrow key to get out of that exponent. Minus 1, and then close for the brackets. Hit my down, and then put 0.04. And before I hit enter, I just want to double check 8,000, 1.04 to the 30th minus 1 over 4. So, all right, so that should do it. So now I'm going to hit enter, and what we see is the amount over here. Now, it says find the value of the annuity. One more time, depending on what it tells you to round it to, now the value is going to be $448,679.50. However, if they ask you to the nearest dollar, this is different than what I just mentioned. When you are calculating, let me back up just so you can see that again. when you are calculating the payments needed, which is a different thing. When you're calculating the payments, we're going to round up. Otherwise, you're going to round to what they tell you to. So here, this is going to give me $448,679.50. $448,679.50. Now that's the answer to part A. But look at part B. Part B says find the interest. So what does that even refer to? Well, in other words, the amount that it's worth is certainly more because of the interest rate it's been drawing than was deposited. We deposited, so for part B, I'm going to take the value of it minus the total deposits. And remember, I deposited, or whoever did, I really didn't, $8,000 a year for 30 years. So that's going to be that value that we just wrote down minus 8,000 times 30. So we get on the calculator. The easiest way to do that is to get your calculator while it's still got that and just click minus, and it's going to be ready to subtract. And then I can do 8,000 and then just parentheses 30, just like I wrote down. So that previous answer minus 8,000 times 30. And I see that the amount of interest over the 30 years was this $208,679.50. $208,679.50. Let's look at another type of problem then. What happens if it's not just compounded once a year? What is our formula then? It looks a lot worse, but the only difference in this formula and the previous one is where you see the n. Previously, it only had 1 plus r. Now it's got 1 plus r over n. The previous formula was divided by r, but now it's divided by r over n. And the previous formula only had t as an exponent, but now we have an n up there. So the difference is the n. What does n represent? N is the compounded n times per year. So you just have to calculate how many times did they compound it a year. And if they only compounded it once a year, if you use this formula, you wouldn't be in bad shape because this formula would just turn into the previous formula. So this is the most critical of those two formulas. So let's work a problem. And again, I've got the little formula down here just so that we can look at it again. Find the appropriate formula. How do we know that this is the appropriate formula? Because it says compounded monthly. So compounded monthly, how many times a year is that? 12 times a year. The other information is the same type of information. So I have my P is 3,000. I have R is 0.07. You've got to move that decimal over. And T is 30 years. So A is equal to 3,000 times 1 plus 0.07 over 12 raised to the 12 times 30 minus 1, and then that's all over 0.07 divided by 12. Having these formulas available is just really critical for you then. Again, that's such an ugly formula. I definitely want to work with my calculator over here, so I'm going to hit clear. To get started with that fraction, alpha y equals enter. Then I have 3,000, open for the bracket, open for the parentheses, 1 plus, now I have another fraction, so alpha y equals enter, 0.07 over 12, close, raise 2, and then up in the exponent I have 12 times 30 minus 1, close for the bracket, and this is all over a fraction, alpha y equals enter, which is so now if you just take a minute and look at it real carefully, I have all of those numbers filled in. So now let's find out what this one's worth. They've been putting in $3,000 a month for 30 years. We're going to put commas in here. We get 1 here and 1 here. So this is $3,659,912 and then approximately 99 cents. 3659912.99. Now that is to the nearest penny, and again, that's different than what they were talking about calculating the deposits. When we calculate the deposit, we have to make sure that we calculate enough in. Find the interest. The interest is going to be the value minus all the payments. The value, which I just calculated, I just write value down so I don't have to write that huge number down again. Value minus the payments, and the payments were 3,000, or the deposits rather in this case, 3,000 that was made 12 times a year for 30 years. So again, while that big number is already in your calculator, we can just take that value and click minus 3,000 that was deposited 12 times a year for 30 years. And then this tells me then how much the interest was. 2,579,000 and so on, so I'll write that down over here. So this one, again, we're going to round that to the penny, so that is 2,579,912 and to the nearest penny 99 cents. The only difference in these formulas was those ends, because it's getting paid more than one time a year, or getting compounded. The interest is getting paid. But now, what if you were trying to make regular payments to achieve a financial goal? And this is particularly the one that we're going to round up to the next dollar. Round up. Regular payments needed to achieve a financial goal. This is actually the same formula pretty much, but it's been rearranged for you. Since it was such an ugly formula, we're going to use this one in its rearranged form, and we're going to remember, since we're trying to achieve a financial goal, we need to round the periodic deposits up, or else we might come out a little bit short. If we're going to get a periodic deposit, that means we're solving for P, so this one's really rearranged for us. Our goal then is how much we want it to be worth. So this time they're giving us A. We have our 7% interest. It's compounded annually, which means N is equal to 1, and they don't have this one rearranged for N equals 1, so we'll just put that in there. 17 years is T. Why would we possibly have a goal that had to be, achieved in 17 years from now? Well, maybe a child is born and you're trying to set aside money so that they'll be able to pay for college or something like that. First of all, you can see there's a large fraction. And then A is my financial goal. That was 140,000. Parentheses, it was R divided by N. However, since N was 1, I don't really need to put a fraction in there. It'll just become the R. R was 7%. Now this is over, open for the bracket, open for the parentheses. It does make a difference, guys. 1 plus, and again, R over N just becomes R, because the N was 1. Raised to the N times T, but N is 1, so that means it's just T. This one had 17 years. Minus 1, close. If you don't get all of those brackets and braces opened and closed, then it's not going to work all at once, and you would need to do it in little bitty pieces, but it's much faster if you can just do it all at once. Okay, so this one says $4,539, and it looks like 53 cents, but this is where we're going to use that information given at the beginning, that they, in this section, they round the payments up to the dollar. So up, first of all, so that's going to make it $4,540. Now, if we put $4,540 in there, and we do that at the end of each year, because we're only going to do it once a year for 17 years, how much of that comes from deposits? So on B, we can say, okay, we get out of $4,540, if we do that once a year for 17 years, how much of that will I get from deposits? Now this time, instead of just using my answer key, since I've rounded that off, I'm going to say 4540, and then times 17, because I only made the payments once a year, and that is, you didn't have much time to see that, did you? $77,180. And so this is from deposits. Now, how much of it then comes from interest? Well, the rest of it comes from interest. So I need to take my goal minus my deposits to see how much I'm getting from interest. All right, so what we've done so far is we've looked at annuities from 3 different things. First of all, if you need to find the value and it's only compounded once a year, you can use this formula. And we did an example with that. If it's compounded more than once a year, this is the same formula except for these 3 little N's right here. On the other hand, instead of trying to find the value of the annuity, if you're trying to find how much the periodic deposit needs to be in order to achieve a financial goal, you want to use this formula that's rearranged for P. We only have one rearrangement of it, but on the one I did, the N ended up being a number 1. But at any rate, that's to calculate that. However, when you are finding P on this particular one, this is the one where you've got to say round up. Round up. Now we're going to shift gears a bit, and you may be looking at something that's a little bit blurry. It is a little bit blurry on my screen because this is a cut and paste of a sample stock report. So we're going to look at stocks, and I'm going to go across and kind of explain to you which each one of these things means. The 52-week high means that is the highest priced during the past 52 weeks. So that makes sense. Now that does not mean a calendar year. This is the running past 52 weeks. So it's not January to December. Otherwise, it is a year. The highest price per share. Similarly, but contrasting, this is the lowest price in the running 52 weeks, in the past 52 weeks. Now this does represent money, so this would represent that this stock sold or was valued at $99.46 a share at its high point during the last year, $34.02 at the low point. Now what is the stock? There's always an abbreviation here, and the heading stock is the company name or the abbreviation that goes with it, and that is FedEx. And every company gets a symbol because no matter how long the company name is, there's going to be some sort of a symbol that would run across the ticker. So the symbol for FedEx is FDX. The heading DIV refers to dividends that gets paid per share to stockholders during the past year. So FedEx paid a dividend of 44 cents per share to stockholders during the past year. Now, they don't put the dollar symbol in the table. You didn't see it over here on the left. They don't put it here. They're just kind of making it as short as possible. But if you owned 100 shares of stocks, that meant you would have gotten paid a dividend of $44. This YLD with the percent sign after it, you could say it's the yield percentage, but most often it's read the percent yield. Percent yield. Okay, and in this particular case, the percent yield was 1%. Down here in the actual table, it doesn't show the percent sign, but this one means 1%. This actually wouldn't be a very great return, because even though they did get a return on their investment, which is better than a loss, that's lower than the average inflation rate. But on the other hand, stock prices might rise. So if the investor sells for more than they purchased it for, then that additional gain would probably make it a better investment than a bank account. On the other hand, if they don't sell for more than they bought it for, just this 1%, they would have been better off just putting their money in the bank. Now, PE, I have a little extra box here about PE. There's some other things that go on, so we're going to come back to this one. First of all, let's just skip over PE for a minute and look at this next one. The VOL hundreds stands for the sales volume in the hundreds. That is not over a year. This just refers to yesterday. So how much of this stock was sold yesterday? Since the number in the table is 37,701, you need to multiply that by 100 to find out how many shares were traded yesterday. 37,701 times 100, which actually is going to move that decimal 2 more places over, and you're going to find out it was 3,770,100 shares of stock traded yesterday. Now the high, as opposed to the 52-week high, the high is the high value yesterday. Yesterday, the highest it traded for was $45. The low amount it traded for was $43.47 per share. And the stock market closed with this particular stock valued at $44.08 per share. It closed then a little bit lower than yesterday. This number here is negative 1.60, and that means that the share of FedEx stock went down by $1.60. So you've got to imagine however many shares of stock you own, you would multiply that by the net change, and that's going to be your value from day to day. So the values of investment change from day to day. Now, if it didn't change, if it closed the exact same price today as it did yesterday, they would just put 3 dots there, an ellipsis. So this is not me telling you there's something else coming. It's telling you exactly what it would say in there if there was no change. All right, so now let's go back and look at that PE heading. This PE stands for price to earnings. Down in this section, there's just some key words here. We have the closing price compared to the earnings, but the earnings are annual. The closing price was yesterday. So the PE, the price to earnings ratio, means that you can take yesterday's closing price and divide it by the annual earnings per share. Now, just doing a little bit of algebra with that, just rearranging, we can find out the annual earnings per share, and you will have to do that in your homework, can be found by taking the closing price and dividing it by the price to earnings ratio. Now, this actually is easier to do because these two pieces of information are given to us. Like in this particular example, the closing price was $44.08, and the PE ratio was 19. So if we take $44.08 and divide it by 19, It equals $2.32. So that would mean that this FedEx had earned $2.32 for the annual earnings per share. And that's really saying that yesterday's closing price is 19 times greater than the earnings. But don't worry too much about that. This second formula, though, is the one that you're most likely to use, because that gives you the given closing price divided by the given PE ratio, and that'll tell you your annual earnings per share. But yet there's a couple of rearrangements about that. So now we're going to take this and we're going to apply it to a different stock report. It'll still be a little bit blurry. I have it split up onto 2 slides because they do ask you a lot of questions. There's a lot of information on that little stock report. So let's just kind of go through. This stock report has to do with Disney, and you can see that right there where it says stop. What were the high and low prices for Disney in the last 52 weeks? So we will kind of write these answers on here best we can. So the high price for the last 52 weeks is $42.38. The low price for the last 52 weeks was $22.50. And by the way, if you're asking, this book was published in 2019, so this information was really about a previous date. This was an actual stock report, but it certainly wasn't from COVID times. Now, if you owned 3,000 shares of Disney stock last year, what dividend did you receive? Well, if you look in the dividend heading, it says the dividend paid was 21 cents per share. So in order to calculate that one, we're going to take the 21 cents per share times the 3,000 shares. And that comes out to $630. Now, what is the annual return for dividends alone? Again, for that annual return, then you want to take the yield percentage. That yield percentage is 0.6%. Now that's less than 1%. It's already got a decimal in it, so that's less than 1%. How does that compare to a bank offering a 3.5% interest rate? That is much lower. Now, does that mean that whoever had this 3,000, if you've owned 3,000 shares of stock, would you be better to have just had your money in the bank? Well, it really kind of depends on the price that you bought it at. That's a very individual thing, the price that you bought the stock at and the price that you sell it at. Because the Disney shares can go back up in value and they can increase. And once they increase in value, then if you were to sell it at a higher price, you might actually end up making back that money. But just directly based on dividends, it is a lower rate. Okay, we've got the same stock report on the next page, but we've got the rest of the questions. They had A, B, C. Oh, look at these crazy letters. D, and then D, and then D. You know that's nuts, but we're going to go ahead. That's supposed to say D, E, F, G, H, but we're not going to worry about that right now. How many shares of Disney stock were traded yesterday? Okay, we'll just look at the questions. Traded yesterday. Well, the number in the table is right here. 115,900. But it says that is the volume in hundreds. So you need to multiply that by 100. Which ends up sticking 2 more zeros at the end, or moving that decimal over 2 more places. So now if I put commas in there, we see that yesterday they traded 11,590,000 shares of stock yesterday. What were the high and the low prices for Disney shares yesterday? Well, the high was $32.50. Just pulling that directly off the chart. The low was 31.25. What was the price at which Disney shares last traded when the stock exchange closed yesterday? So close is our key word there. So you look at the close column heading, $32.50. So it actually closed at its high. What does the symbol in the net change column mean? Aha, see those three dots? Told you. If there's three dots right there, it means there is no change. That means there was no change from the previous day's close. Not just no change ever, but no change. And that no change is from the previous day's close. So it went up and down a little bit during the day between 32.50 and 31.25, but overall it closed at the same amount that it had before. Compute Disney's annual earnings per share. Now the annual earnings, again, this is the way that this is generally used. We're going to take the closing price per share and divide it by the ratio they give us. So that means we have $32.50 for that closing price. And then we are going to divide that by the PE ratio, it says was 43. And do that math. This ends up being a dollar amount because it's our earnings. At least it's positive. It means we did make headway, and we end up with 76 cents. The annual earnings per share, and you can see that's labeled here, the annual earnings per share of this Disney stock was 76 cents. The ratio, the PE ratio, the 43, means that yesterday's closing price, $32.50, is 43 times greater than your earnings per share. So that's an example all the way worked out of how to do that. And that really covers it. Again, what we've dealt with is the stock, and then we've done annuities, whether or not we were calculating annuities. So whether or not you're investing in stock, trying to save money to reach a financial goal, that's definitely where you round up, or whether or not you are looking at the value of annuities. And that finishes today's lesson.